Did you know that up to 35 of CompTIA Data candidates fail their exam on the first try? Will you be one of them? Not if you prepare the right way. Let's see if you can answer these real questions from our practice tests. Question 1. An urban logistics platform needs to model couriers, packages, hubs, streets, and time-bounded road closures for real-time rerouting. The feature must answer COP path and neighborhood queries. For example, find all hubs within 4 hops that can handle a commodity constraint while ingesting thousands of relationship updates per minute. Their current relational approach requires deep join chains and frequent schema changes as new relationship types are added, causing latency spikes during peak hours. Which database type should they choose as the primary store for this feature? A. Document-oriented database with embedded neighbor lists per hub and courier. B. Column family wide column store optimized for high write throughput and denormalized rows. C. Native graph database property graph as the system of record for nodes and edges. D. Relational database augmented with JSON columns and materialized path indexes. What's your answer? Take a moment to think. The correct answer is C. This question tests selecting the appropriate database type for relationship-centric, multi-hop traversal workloads under frequent updates. Graph databases are optimized for path queries and evolving relationship structures, providing efficient traversals and ACID consistency. A common pitfall is choosing document or wide column stores for their flexibility or scale, overlooking the cost and complexity of multi-hop traversals and join-like operations. Question 2. A retailer stores orders in a table. Orders and status changes in order status history order id, status timestamp, loaded at. The analytics team must produce a daily snapshot returning 1 row per order with the most recent status effective on or before 2024-06-30-235959 UTC, regardless of when the change was ingested. Late arriving updates are common, and the snapshot must not duplicate orders or pick a status that became effective after the cutoff. Which query approach best meets these requirements? A. Join orders to a subquery that selects per order ID the row with the greatest loaded date before the extract time and return that row's status. Join orders to a derived table that selects per order ID max status timestamp, then join back to history to fetch the corresponding status. C. Filter order status history to status timestamp cutoff, then use row number over partition by order ID, order by status timestamp desk, and select only rows with RN1 before joining to orders. D. Left join orders to order status history, where status timestamp cutoff and status in shipped, delivered, then use distinct to remove duplicates. What's your answer? Take a moment to think. The correct answer is C. This question tests building an accurate ASOF snapshot using query logic that respects effective time cutoffs and avoids duplication. The correct approach applies the cutoff to status timestamp and then uses a window function to pick the single latest row per order. A common pitfall is using load time or aggregations without filtering by the cutoff first, which yields future effective statuses or unstable duplicates. Want more questions like these? The full course contains 540 similar scenario-based questions. Why choose our course? Because we provide detailed, scenario-based questions with deep explanations for every single option. Get instant access to 540+ questions and 6 complete practice tests. Start passing today with our 100 success guarantee.